My topic tonight is cell phones. Just kidding. I'm going to try and make it lighthearted. I'll usually spend 5, 10, 20 minutes talking when I should just start with the power presentation. So I might as well start now and just kind of introduce myself. Why? Because there's a slide for that, so I might as well. I've titled tonight Solving the Mysteries of Autism with a question mark. Current research on functional medicine and neurological approaches. So I'm Dr. Russ Schroder. I'm a functional neurologist, board chiropractic, certified chiropractic neurologist, etc. My background was in chiropractic. Got kind of bored with that, seeing some of the limitations of what it can and can't do for the body and different types of therapies and interventions. Back in 2008, I began training to go through certification in the chiropractic neurology field. You can drop out the chiropractic neurology. They basically created a new field because it's hard to become a chiropractic neurologist if you're a medical neurologist because you didn't go through the chiropractic. So they created the field of functional neurology about a decade ago. There's only about 100 of us so far. I took the 3-day exam in chiropractic neurology, the 2-day exam in functional neurology back in 2011, and I passed on my first try. So, yeah, only about half the doctors do. I'm a local boy. I'm from Duncan Falls, Ohio. We went to Philo High School where they taught us how to read and write and maybe not how to speak or pronunciate too well. So if I say ain't or can't, it's just because I'm from around here. Went to Ohio State, went on to Palmer College, went on to study the functional neurology at the Carrick Institute. More about that in a moment. I'm one of the charter members of the IAFNR, which is the International Association of Functional Neurology and Rehabilitation. When I say functional neurology, it just means that neurology is neurology. How the brain works, how the nerves fire. It's just that we're not in there prescribing medication or doing surgeries. That's what medical neurology is for. Well, medical neurology is missing out on a good portion of how the brain works because of their intense focus on some of the things that can't be fixed without medicine. I studied functional blood chemistry, endocrinology, neurotransmitters with Dr. author of the book, What Do You Do When the Medications Don't Work? I'm the neurology director at the newly formed Mind Institute for Neurological Development in downtown Zanesville. And I'm author of Bucket List Avengers, a functional neurologist's extra experience in the #3 movie of all time. This is the book. That's Captain America. This is Cleveland, Ohio, not actually Stuttgart, Germany. And here's this guy. So, I want to give a copy to Shannon. Thank you very much for having me.
Well, thank you.
There's very little about functional neurology in there. I say that towards the end. It was just about the experience of getting a chance to fulfill a childhood dream of trying out for a movie and actually being cast in it. And then I didn't tell anybody for 9 months before it came out last year in May, because I didn't know if even that little shot right there would be in there, or if it would be the top of my head bowing down to the bad guy, or if it would be running around like we did in that scene for 2 nights straight. I've also studied under Dr. Robert Melillo, author of the books Disconnected Kids. I left off Reconnected Kids. Autism, the Scientific Truth About Preventing, Diagnosing, and Treating Autism Spectrum Disorders, and What Parents Can Do Now. It's a brand new book, copyright 2013. That's pretty recent, right? January 1st, just came out on Amazon, as is my book and his old books. He is also the go-to guy on Fox News and New York and all the other ABC, NBC channels because he's the one fighting for families and the kids. He's on there trying to get them the best care that they can. He's the one slapping down the rumors about Asperger's, which of course no longer exists because the new DSM-5, let's just lump that together. It's all the same. He's the one fighting to kind of quench the rumors of it being an issue with are Asperger's kids dangerous? He was the one that kept calling it, as well as a small group of other individuals about the Newtown shootings. Rumors about whether the kid was or wasn't. He's pointing out that it's not a danger. It's just there's some social issues. It's part of how the brain is wired. And he's also the founder of the Brain Balance Centers. He talks about brain balance a lot in the Disconnected Kids. The Reconnected Kids was a follow-up because let me ask this first question before we get too far in. How many people, especially knowing about the Sunrise program, how many people think that there's a definite chance to reverse or correct autism and autism spectrum disorders and Asperger's and these type of things? Okay, good, because otherwise why are you here except to be educated about something that can't be fixed? So we know from his research from around the world, Dr. Leisman, who he works with, this gentleman right here who founded the field of chiropractic neurology. This is from Nightline from October. This was the one time when they actually said, oh, there's a chiropractor working with patients with head injuries and nerve problems and brain problems. And I think it's the one time in the history of the world when they didn't bring some know-it-all medical wannabe pharmaceutical-based doctor to say, well, there's no research for that. That doesn't exist. It's all placebo effect. Dr. Carrick is the one they called in to work on the Pittsburgh Penguins' famous Sidney Crosby, who is basically considered the next Wayne Gretzky. So in 10 years, he'll be the one that they're talking about. He was knocked out of hockey for 9 months after 2 consecutive dings to the head. Couldn't skate, could barely stand up, was nauseous, was dizzy. That's a serious brain problem that's going on when you can barely interact with gravity. He went to work on him, and a week later he was skating, and a month later, after some practice with some high school teams, and of course he's wearing a bright orange helmet, so they say, that guy makes $8 million a year. If you body check him, gone. And I don't mean from the team, I mean we're going to throw you in jail, and everyone in Pittsburgh and Pennsylvania and Eastern Ohio will hate you, and you'll be the pariah of the world. So he was skating a month later, skating a week later, and played it later on that year, still made it to the whatever the hockey all-star game is. And until he got dinged in the head later in the year, because you can always go back and re-injure something, right? If you kind of recover from a concussion, you can still go back and have another one. If you sprain your knee but do rehab, you can go back and hurt the knee again. So he went back to him, and he fixed him up, and he was skating again. So he's getting known for that. Traumatic brain injuries, there's been about a half dozen different hockey players whose careers were practically ended because of the severe damage they were having from getting dinged around, having inner ear damage, the connections, the nerves that are in the brain. Has been working with other professional athletes. Dana Torres was one they had the news. And yes, he was the one who was featured on Nightline with the work that they're doing with all the doctors in the white coats down at the Functional Neurology Clinic down in Life University in Atlanta, Georgia, where you'll see the big spinning machine that a year ago there was only 3 that existed in the world. One was at NASA, one was at the Life Functional Neurology Clinic, and one was at the Mayo Clinic. And now doctors are actually starting to use the big spinning multidimensional basically nerve and brain rehab unit. It's just kind of pricey, like an MRI machine. Wish I had one in my back room, but I don't. Both an MRI machine and one of those big spinning deals. Anybody recognize Zach Brown? This guy? Hope we're on a Friday night. So he is the only singer in country music or regular who had 5 #1 singles off his first album. He donated his winnings from the CMA Award to the Carrick Institute. There were 2 things that he has wanted to do throughout his lifetime, just passionate with this. One is work with kids, and one is play music. So he's actually developing the Camp Southern Ground, which is designed to work with children with behavioral and learning disorders. So he actually, back in the day, a few years ago, when the book first came out, he would stop and do a 5-minute PowerPoint during one of his concerts and actually talk about Dr. Melillo, brain balance centers, disconnected kids, and what it all means. So it's really cool stuff. I'm trying to learn from the best, not just the naysayers, which brings us to the members of the Flat Earth Society. Okay? And I remember this from way back in school. I had a professor, and this was just simply with like chiropractic and back pain. Okay? We won't be talking much or at all about chiropractic tonight. It doesn't apply. It's not what we do at the Mind Institute. But this was just an instance where it was one of the law professors. He covered a few topics. Lots of different teachers in college at the schools would do a couple different classes. And he was like, this was based on trying to get insurance coverage just for patients that were in a certain network. And he basically had just like 11 studies back in the early 80s, and was like, here's one, just lay them all out. It's like this one shows that chiropractic can help with back pain, this one, same, couple for neck pain. And then he kind of just, took his little turn in line, because there was other doctors, massage therapists, and podiatrists and stuff, and eye doctors fighting for coverage and fighting for care and being included. And the medical doctor got up and just kind of said, I don't care what any of those said, because I don't buy it, I'm not into it, I won't hear it. Anybody ever had that happen in life where no matter what proof you gave them, a study that, showing that orange juice might be good for your health, a study showing that gluten might be bad for you. Have you ever tried to convince anyone on gluten or dairy, food sensitivities, food allergies? I'm not going to be speaking to those people tonight because I'm assuming you're already ready to listen. Okay? That the walls are not closed off, that you're open to hearing some of this research, because there's a lot of powerful research that's going on in the United States, in the world, and we'll be referencing from like as far away as Rio de Janeiro and Russia and Spain, because it's obviously a very important topic to dig into when you've got something that is in the realm of basically being considered an epidemic. Anyone heard the term epidemic in response to this? Because, if you look at the numbers, we'll go over it a little bit. The cool thing about Dr. Melillo is this book did just come out, but when I first got it, I was looking at the back. Has anyone ever heard of Dr. Daniel Goleman? Or Emotional Intelligence, one of his books on that, or not the IQ, but basically emotional intelligence, but it's the emotional quotient. It was like called EQ for a while. It's like, how responsive is someone to other people's emotions, which obviously applies in the ASD field. Leslie Philip Weiser of Harvard Medical School, Alicia Halliday, the Director of Research for Environmental Sciences at Autism Speaks. Dr. Melillo spoke at Autism Speaks last year. Zach Brown's on there, and the intro is by, the name eludes me, but he is he is the head of something special. He is a professor at the Department of Pediatrics, University of Kentucky College of Medicine, and the director of the National Institute of Child Health and Human Development. Joab Merrick, MD, Doctor of Medical Science, DMSC, all the extra alphabet soup that goes at the end of someone's name when they've spent a long time trying to learn about a certain topic or going to different locations and schools. So I'm going to take this flat earth and make it as round as possible. Much of what I'm going to be talking tonight is not about the statistics. It's not about some of the research in the nutritional field, although that of course applies. I have a slide that I put in about an hour ago because I basically had to take a picture on my cell phone, email it to myself, and take one of the research papers that Dr. Melillo and Dr. Leisman did, explaining how just looking at brain function, they can explain, in essence, how we can have a multitude of different factors that are related to gut, that are related to like yeast, that are related to pH, that are related to metals, heavy metals. Because everyone has heard about, basically enzymes for autism or heavy metals. There being a yeast connection, leaky gut, of course. LGS, leaky gut syndrome, is pretty well known in regards to this field. So today I'm going to be approaching mostly the neurological approach, how the brain works, how it's supposed to develop, when it doesn't develop appropriately or certain parts don't develop appropriately, how that can affect the whole body. Okay? So, current, it's 1 in 88, when back 20 years ago, the statistics were more like 1 in 10,000. I know it's hard to stay on topic just with autism or autism spectrum when we're talking about the functions of the left and the right hemispheres, because that's a lot of what we're going to do today. There's some books that I'm going to recommend. I'm glad you all brought something to write with. I'll try not to draw too much. And towards the end, if I forget, I'm going to remind you that if you want this PowerPoint, then just send us like a mail or an email, and we'll actually, I'll turn this, because it's hard to read on the background sometimes. It's better that it's not a white background, because it kind of gets washed out, but on printouts, it looks much better with the white background. So if you want this, I will get this to you as is. All the research that I talk about tonight is in the peer-reviewed medical literature. So the National Institutes of Health, there's a big building in Bethesda, Maryland, where there's like 22 million different research papers. To get to it, you go to pubmed.com or pubmed.gov, and it's the National Clearinghouse for Research. So I'm not pulling something out of Dr. Russ's little pocket. I'll be explaining some of the research that we have, not really research, but some of the case examples that we have from the pilot program starting at the Mind Institute. And we'll go over that here towards the end. So I'll try and stay on topic, If there are any questions, I will be happy to address them during. I'll pretty much give you the answer as it is, or I'll tell you I don't know, or I'll tell you we can't know that yet, or it may be impossible to know based on, you may have to cut somebody open and look at them directly. So, went from 1 in 10,000 to 1 in 150 to basically like 1 in 88, and the newest Korean study, which was actually a few years ago, estimated that some said 1 in 38, some said 1 in 67. So I know it's all based on just kind of cohort looking at the population and trying to summarize. So it's all going to be kind of guesstimates and estimates, but there's definitely something that needs to be done as society as a whole. Okay, so I'm going to start with something from the Senate hearings from 2006. Thomas Insel, he is head of the National Institute of Mental Health, part of the National Institute of Health, and the chair for Interagency Autism Coordinating Community. Of course, lots of big words because it's the government, so we can't simplify unless they start using, just combining it together, NIH and NIMH. He basically came out and said, pretty much because you can't have a genetic epidemic because it has to be passed along, from gene to gene to gene. You don't go from 2 people that don't have a problem to suddenly a child that has a problem genetically. It's pretty tough to do, if not, basically they say impossible. Genes alone do not tell the whole story. Recent increases in chronic childhood disease like diabetes, childhood asthma, obesity, or autism cannot be due to major shifts in the human gene pool, as those changes take much more time to occur. They must be due to changes in the environment, including diet and physical activity, which may produce disease in genetically predisposed persons. So let's talk about breast cancer, because they're basically a BRCA gene. It's like BRCA, so they call it BRCA, and it is linked to breast cancer. So the problem is, not everyone that gets breast cancer has the BRCA gene, okay? And not everyone that has the BRCA gene gets breast cancer. So it's kind of one of those things that just seems to occur, so it's like a compounding type problem, but it doesn't mean like, okay, if you have blonde hair, all of a sudden you're going to get X, Y, Z, okay? If you've got more hair than me, much more, congratulations. So, you are not going to be just predisposed to the problem just because you have hair and I don't. It's not that one-to-one type ratio. And again, if you want this later, so this is from the http://www.genome.gov, because you can go log right on there and you'll see a little National Institutes of Health, National Institutes of Mental Health, the CDC, all those little logos at the bottom. So this is from a government website. And believe me, I'm not like, yay, government. Who was in this last election? Anybody raise your hands? I don't see any hands raised. My eyes are open. Okay, so the talk about being genetic is only as a co-founding problem. So it's a link, but just because you have a gene doesn't mean you're going to express it. There's something called epigenetics, which is the actual expression of genetics or not. It's like the environment combined with genetics. Anyone heard of the Agouti mice? I want you all to write this down so you can Google it later. A-G-O-U-T-I. They're basically a strain of mice that they raised just for research, and in about between 1999 and 2005 or so, they were doing research on them because every gene line is the same. It's like the mother is the daughter. Okay? So they took these mice and they changed, and basically they raised them because they're big, fat, sick mice. They're like these brown, like if they were humans, they'd be like 400-pound mice. Almost all of them have diabetes and hypertension and high cholesterol, and they breed them to be that way so they can test them. They took one change, and they gave them what they call methyl donors. Okay? So they're like basically B vitamins. All right? And they gave them these methyl donors to eat, just like in a pill form, just like we take vitamins every day. And they found that their homocysteine level was lower. Homocysteine is related to inflammation. So if you lower inflammation, you lower a lot of risk for health problems. That's what they were in fact trying to do when they were trying to take Vioxx and use it as an anti-inflammatory to possibly treat cancer or bowel disease or inflammation in the brain. And they found that just medically trying to reduce inflammation will cause a lot of side effects if you're not doing it right. That's why fish oils actually do it in a better way. It's not my topic for tonight. But they gave them methyl donors, and the very next generation was like the slender little yellow Olympic-style mice. So you went from having this big, brown, sickly, overweight, standard American diet type mouse to a nice, young, healthy, fit, Olympic-style, healthy mouse. they check the genes, so they get to kill rats. It's not cool to be a rat around a researcher, but hey, at least they give us something to look at. They took them, they looked at their genes, and they found that the genes didn't change. The same piano keys on a piano were just like they were on the previous piano that was made. But they changed the expression of the gene. So how does that work? Well, genes are proteins that are wrapped up. It's like cytosine and tyrosine, and you know how they have that coating, that wrapped up like double DNA helix? Well, if it gets too tightly wound, then those little things that come along that read the mRNA, DNA and turn into mRNA and create proteins in the cell, if it's wound too tight, then it can't read everything in sequence. It like jumps around. So it didn't actually, it's like what the methyl donors did was allow it to uncouple so it could read it effectively around the helix. Same genes, different expression of the genes because of the way the gene was read. Okay? So too tightly wound and you can't get it all read, you give the methyl donors that can unwind and it can be read appropriately. They didn't change the gene, just the reading of the genes. So when they talk about if the genes are the piano and you may have the BRCA gene, all right, and that's a piano key, that's a gene that you don't, that's like sitting right there. If you're in control of your destiny, which most of us believe that we are, especially nutritionally, lifestyle-wise, health-wise, for the most part, as long as you can do everything you can to avoid playing that key, and you can't change whether you live at 3 Mile Island, or if you were in Chernobyl, anywhere near there, if you were near Nagasaki when the bombs went off. Okay, kind of hard to avoid radiation if it's a few miles away from where a bomb went off. But otherwise, if you can decide, all right, maybe my child is gluten sensitive, maybe test them for that, and they're gluten sensitive. If you don't play that key because you don't give them gluten, then you don't have to worry about the expression of that gene on the piano. Pretty cool, huh? All right, so just speaking in terms of general like ASD, autism spectrum, cost to a family, because this is very important, because it's almost crippling to families that if they have one child or 2 or 3 that are on the spectrum, it becomes more and more and more a strain on the family, financially, psychosocially, interdynamics between husband and wife and children, grandparents, the extended family, the schools. So just in terms of cost, this was a study done in Archives of Pediatric Adolescent Medicine, which is now JAMA Pediatrics, so they bought it out or whatever, and now it's part of the Journal of the AMA. But Michael Gantz took a look at the overall lifetime cost, and for coverage for direct and indirect costs, meaning medical as well as time lost from school, possibly the spouse having to take a lower paying job so that they can actually be home more often, even if it's at the expense of working 20 hours a week to be there with the kids so they don't have to pay for the babysitter or daycare or something. It's cost direct as well as indirect. $3.2 million per child. Well, doesn't become a child anymore, it becomes for a lifetime, of course. So $3.2 million per person for the family. So we're going to put that in numbers for the for society, for the government here towards the end. But it's obviously not good and getting worse. All right. So I like to start this off with a question that many times Dr. Malilla does when he speaks. So, who can tell me what is happening in the brain of a child with autism? Okay. Let's rephrase it. Raise your hand if you have no idea what is happening in the brain of a child with autism. I do want to see the hands up high if you're pretty sure that you're not certain what some of the mechanisms are. Okay. So, that's what we're going to talk about here tonight. What we do know about brain development in autism spectrum disorders, and to some extent ADHD and dyslexia, because we're talking hemispheres, and what they do because they're totally different. All right, so this is one of the papers done by Dr. Malillo. Dr. Leisman, you'll be seeing his name. If you go to that PubMed database, he's got like 70-some different studies that are in the peer-reviewed literature dating back to the 60s and 70s on the split brain type research. So the split brain research goes all the way back to the 50s and 60s. Roger Sperry won the Nobel Prize in '81 for his research on split brain research. So in the University of California, they were looking at people that have like seizures and epilepsy. So that's basically overactive piece of the brain that starts to spread. The electrical activity goes from one place all throughout. So it can often go from one side to the other side. You can lose consciousness and the whole body can go into spasm. Right? So University of California, out in California, they have wildfires, right? How do they try and prevent or stop the spreading of a wildfire? They either burn out a strip or dig out a strip in between where the fire is at and where it's going to spread. So if you burn it in advance, a controlled fire, once it finally gets to there, it can't burn any farther because it's already burned out. So it's preventative. Or they can just dig some big trenches and hope that whatever doesn't blow across, they can dig that out and just pour down a bunch of water, anything but gasoline, tear up a whole strip 20 or 30 feet wide, get the bulldozers out so it can't spread. In the split brain research in regards to what the right hemisphere and the left hemisphere do, when they found patients that had seizures or epilepsy on one side of the brain, they could cut this little section down between, which has a name later we'll talk about, which is the corpus callosum. Okay, it's like the Golden Gate Bridge of nerve connections, and it connects the left to the right brain. And I'm going to try and talk as little with my hands as possible because that's why I put pictures in here, but I can't help it. Wendy, if you want to grab one of those seats and right around that corner over there, there's some. So, if you don't want to stand. So they were what they did, and this is back when they were actually taking and doing lobotomies for people that had mental conditions, like in the 40s and 50s. So in order to not just destroy half the brain, what they would do is sever the communication between the left side and the right sides by taking that huge bridge of nerves, that huge Golden Gate Bridge of nerves that connects the two, and just separating it so that it couldn't spread from one side to the other, wherever it started on. They thought people looked pretty normal, pretty healthy, pretty consistent like they did before for a while. And then they started noticing different kind of weird things, like they would have their hand, they'd be moving it, and it'd be resting on their body for a while, and all of a sudden they'd look down and they would forget that it was their hand. The right brain, the right hemisphere, and I'll use the term right, left brain, but we talk about hemispheres, when they weren't communicating to each other, that they would actually start to lose track of where the other side of the body was. Pretty interesting stuff. A lot of what we're going to talk about tonight is based on different research from patients who have head injury, patients who had stroke on one side of the brain or the other, patients who had a tumor where they had to have it taken out, or even like cases with seizure where they had to cut out that part of the brain, and there's a big pretty slide on that later, that shows us the left side of the brain and the right side of the brain are different. Okay? They grow at different speeds, they grow at different times in life. If they're not wired together as effectively as they should be, then we start to see some of these problems. So, back to this. This was their 2009 paper, and they basically were outlining autism spectrum disorders as a functional disconnection. So if you type in autism and functional connectivity on the government database, pubmed.gov, med.gov or .com, that's when you'll come across 100 and some different studies just talking about autism and autism spectrum, as well as even dyslexia and ADHD, as being a communication problem between hemispheres of the brain. So they basically said we're outlining the basis of how a functional disconnection, not damage, not trauma, okay, not something that got cut, not where they went in and separated something, like trying to prevent the wildfires from spreading from one side to the other, but just a functional disconnection, where it's not firing as appropriately. Some of the lanes on the highway are busted, so there's only a limited number of lanes to get from one point in space to another. A functional disconnection with reduced activity and coherence is basically just the summarization of the right side of the brain as it goes through the information that it does, communicating with the opposite side. Coherence in the right hemisphere would explain all, and they use the word all because for a reason, and I'll talk about that later. All of the symptoms of autism spectrum disorder. Now, here's the most basic, obvious question. Is everyone who's on the spectrum the same? Do they have the same symptoms? Are they the same age? Are they the same sex? Do they have the same limitations, the same skills and abilities? No. So we're not talking about one solid thing. That's why they call it autism spectrum, okay? Because it's not one set thing. It's a spectrum along that continuum about how well things are developed, how well things are functioning. So they said decreased activity in the right hemisphere would explain all the symptoms of autism spectrum, as well as some of the observed increases in sympathetic activation, which is like the fight or flight response. So when we talk about sympathetic activation, that's the picture that I took of my phone, that I emailed to my computer, that I put on the slide so we can see how that could cause leaky gut. If you have leaky gut, guess what can get in? metals, toxins, food particles. Yeast can grow because the immune system isn't as strong. If the problem of autistic spectrum disorder is primarily one of desynchronization, things firing inappropriately, not firing from point A to point B, not being caught up to speed, I've got pictures, and ineffective interhemispheric communication, left versus right, then the best way to address the symptoms is to improve coordination between areas of the brain. So there's the Golden Gate Bridge between the two hemispheres. We're going to see that in a second. If it's down to one lane, it's not going to work as well. Who's heard of agenesis of the corpus callosum? Okay, that's when it actually doesn't grow. You know, the character that Rain Man is based off of, Kim Peek, had a photographic memory. In fact, he couldn't forget things. You can Google Kim Peek, you can Wikipedia him. It's where there's no separation between the two lobes of the brain or the two hemispheres. It's all one big thing. So there is no bridge between the two. So he could remember things, everything that he read or heard in theory. Basically, that's what they tested him, and he couldn't forget things. But that's also a problem. You can't forget things, right? There's some things in life you want to forget. Okay, on with what they said. To do that, the best approach, treatment-wise, would be to include multimodal therapeutics, big word, just means therapies, that would include a combination of somatosensory, cognitive, behavioral, and biochemical interventions, all directed at improving overall health, reducing inflammation. I mean, pretty much everybody in America, for the most part, needs to reduce inflammation. That's why they give you NSAIDs. That's why you have to take aspirin. Reduce inflammation and increasing right hemisphere activity to the level that it becomes temporarily coherent with the left hemisphere. I'll explain that in pictures later. We hypothesized that the unilateral increased hemispheric stimulation, the treatment to stimulate the right hemisphere, to bring it back online and catch it up with the left, has the effect of increasing the temporal oscillations. All right, let me just take a breath because this is getting tiring. I don't mean to beat your head down with research and big words. That's why I'm going to summarize and talk in pictures. But I got to present it because you can take this, throw it online, find it, and any neurologist that doesn't know this, any neurologist that wants to have a debate with me, I'll sit and have a debate any day of the week. I'll talk about autism. I'll talk about diabetes. I'll talk about fibromyalgia. Okay, that's exactly what functional neurology is about. It's like, okay, if they got sick from a certain thing and they quit doing the certain thing, you think they might get healthier. If you get diabetes from eating all this terrible sugary food and you treat it, you take them off the sugary food and give them some supplements to help with absorption so the insulins work better, do you think maybe they can reverse that? Of course, Dr. Oz talks about it. All right, so by bringing the speed, the oscillations, and the thalamocortical pathways, I'll explain that later, bringing it closer to the speed, the oscillation rate of the properly functioning hemisphere, yawn, we can propose that increasing the baseline oscillation speed of one entire hemisphere will enhance the coordination and coherence between the two hemispheres, allowing for enhanced motor and cognitive binding. I'm so sorry I had to put that together in one big slide because what it really means is this. All right? There's three parts of the brain. There's the cerebellum. Cerebellum, you know the word cerebrum. And basically take that out, you've got cerebrum. That's the big brain. We'll get to that in a second. Cerebellum literally just means in Latin or Greek, and I never try to keep track because it's either Latin or Greek. It's what it all comes back to in science, in medicine. My sinuses are swollen. You've got sinusitis. Did he diagnose you or just translate it into Latin? Translated to Latin. Itis is inflammation, and then sinus is the word. So he just gave you, and if it's acute sinusitis, that just means new. It just just this past 24 hours. So cerebellum means little brain, in Latin or Greek, I never keep track. The cerebrum, which is the big brain, we'll talk about the cortex. We'll talk about the hemispheres, the left and the right. We're actually looking at it from the front, just so you know. So that's the right hemisphere. And then the brainstem. Okay. Cerebellum fires. So, you know how in science they talk about if somebody has injury or damage to one side, that it affects the other side? Because one hemisphere controls and senses the other side of the body. That's true for up here and halfway down here. This part here is actually same-sided. It's already crossed over, just so you know. So by the time we get down to here, that's why this one was done on this side. That's why this slide is that way. Because the left cerebellum is involved with coordination of the left side of the body and it fires information up to the right cortex. It is involved with balance, coordination, eye movement, and in the last 10 years, hugely they've found that it has influence and effect on cognition, thought. Okay, actually, some studies show that it'll fire at or before when up here decides to fire, when you think a thought. So a lot of focus is on here. We're going to get to that in a while too. All right, so the corpus callosum is the bridge. It's the Golden Gate Bridge of nerve fibers. It's the largest nerve communication in the body. It communicates one hemisphere to the entire other hemisphere. Diffusion tensor imaging, I'm going to show you a beautiful picture of that in a minute because they use all different colors of the rainbow to show which way the nerve fibers go in connection. Diffusion tensor imaging in autism spectrum disorder, the preliminary evidence of abnormal neural connectivity. All right, so this one was done in 2011, yet they use the word preliminary, which is strange because I'm going to show you something else in a minute. They said in their conclusions that this study provides preliminary evidence, and again they use that word, of impaired neural nerve connectivity in the corpus callosum. So the bridge in the Golden Gate between the left and the right hemisphere is impaired. It's smaller. It's not firing as well. Okay? It's a functional disconnectivity. Is it more prevalent? Is autism more prevalent in boys or girls? Boys. Is ADHD more prevalent in boys or girls?
Boys.
How about dyslexia and learning disabilities?
Boys.
Okay. Did you know that the corpus callosum and the Golden Gate Bridge is biologically bigger in women? So the Golden Gate Bridge has an extra lane or two, okay, in women than it does men. So who's better at multitasking and being able to keep track of multiple different things? We all, I know, we're at and it's true, all right? Because you got to be able to keep track of, more detailed, more involved, more coordinated. They say that the male brain just has to be, smart enough to be able to go out and stalk the elk and the deer, and barely smart enough to drag it back, okay? And that's about all we're good for. That providing the other half of the chromosomes. So, their preliminary research from 2009 says that there is impaired connectivity between the hemispheres. The Golden Gate Bridge is smaller, or the lanes are blocked. There's a problem. So, ignoring that one, let's look at this one first. When you see a side view, it just doesn't look as impressive. It just looks like, okay, it looks like something. It looks like a bone. It doesn't look like it's actually fanned out and as expansive as it is. And in reality, that thickness right there goes all the way from one side to the other. It connects both the occipital lobes in the back, which is where we see. It connects both the somatosensory lobes, where we move and sense. It connects both visual lobes in the front, and to some extent it connects the temporal lobes on the side, where we hear at. It is the largest connection in the body of nerve fibers. Okay? So when I say it's the Golden Gate Bridge, I don't mean it's just the Y Bridge. I don't mean it's the bridge in Southtown where we used to cross over from, right across there, now it's Jobo's Pizza, going across over to Pick and Save, which wasn't there 15 years ago. The corpus callosum is reduced in autistic individuals, which is going to be very important here in a second because of the development of the brain from birth on, actually before birth. Diffusion tensor imaging, that big technical word for what it is, it's a type of functional MRI. So an MRI is like a human deli slicer. They put a non-surgical human deli slicer without all the blood guts. Okay? So you see the guts, but there's no blood. So they put you inside, and it starts to rattle. It goes bang, 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 bang. And basically what it does is looking at that magnet, which is why you can't have metal inside the room because it's a huge magnet, and it can pull. You can't have metal fillings. You can't have metal in your eyes because it can pull it out and just rip through the body. It puts a spin on the hydrogen atoms and measures how fast or how slow it takes for them to quit spinning, because different tissue has different amounts of hydrogen, and they have calculations based on how dense it is and how fast the hydrogen ions quit spinning will tell you how thick it is, or how dense, or what it's made up of. So it's a type of functional MRI, and the functional MRI looks at blood flow. Like, actually, if somebody thinks a thought, like, we're going to do a little test. Everyone just close your eyes for a second. I promise I won't come up and tickle you. Now, imagining you've just close your eyes, it's okay. I won't tickle you. Now imagine you're in the exact same spot there, but now that imagine you stand up, all right, and you step up onto the table, and how I would look from another 5 foot up in the air, from your leg distance, as well as stepping up on a 3-foot table, how I would look kind of looking down onto me, and if you look to the right and look to the left, the person that you were just looking at. Open your eyes. If we were to put you into those functional MRI machines in a little tunnel, you would have found that the right brain had lit up, because the right brain is involved with where you are in space to everyone else. Left is mostly involved with where you are, internal feelings and small details. Right involved with those on the battlefield around you, so to speak. Okay? The corpus callosum is all the fibers going this way and that way in all these beautiful colors, going up and down, connecting one hemisphere to the other. Okay, Cleveland Clinic, and this is back in 2009. So the 2011 study said preliminary. Well, researchers don't always like to give credit to those who came before them, and they'll self-quote themselves a lot because it's like, well, I found it, I did it, so I'm going to throw my name on there. And every quote that I have at the end, it's going to put me first, and then it's going to have the other 100 people that you get the research from. Cleveland Clinic, the corpus callosum is reduced in autism. A meta-analysis, meaning it's not just like one study, it's like, okay, let's look at that paper, that paper, that paper, and look at all the papers we have that are involved on that topic. So it's a meta-analysis. It's a whole analysis of all of them. And it says that it is reduced in autism. So for those that raise their hand and said they have no idea what's going on in autism now, you have a very good understanding about what is going on in the autistic brain. But there's more to it, and we're going to get to that. So the corpus callosum reductions are present in autism and support the aberrant connectivity hypothesis. The beautiful thing about that is, where's that done from? Cleveland Clinic. Did you know they have a Cleveland Clinic in Arizona now? There's Cleveland clinics everywhere. It's like the Mayo Clinic. It's getting more popular than that. So it's more than about being in Cleveland. It's actually about, like, okay, spreading out the name and the quality that we have. You know what's cool about it there is that the surgeons don't get paid per surgery. That the recommendations from the Cleveland Clinic, as well as from the National, the American, not Medical Association, but one of the associated individuals, basically said that for back pain, they're actually recommending spinal manipulation. And this, again, I'm not talking about chiropractic tonight, but it's kind of crazy that, like, it's come full circle. It's like, oh, don't go to chiropractor, they'll hurt your low back. And now, actually, if it's in the acute phase, like within 4 to 12 weeks, they say, first thing you should do is go to a chiropractor. Or I'm sorry, you should have spinal manipulation. But they have those doctors on staff at the Cleveland Clinic now. And they don't get paid per treatment. They just get paid to work there. So that's kind of cool. It's not like, hey, you got a bad back, you have a bad neck, you need neck surgery. Because it helps him pay for his Ferrari or his Lamborghini. So that's kind of cool. There's a lot of respect for the Cleveland Clinic based on what they're doing with research. And interprofessional research. Reduced corpus callosum. I'm just going to hit these and hit these and hit these. We're going to take the horse, beat it till it's dead, beat it some more, find a different horse, beat it, and keep on beating it. I'm not going to. That's why I'm going to buzz through these. Dear sweet Melissa was at the last one, and she was like, oh my God. Don't talk to us like we're researching. We don't need the big words. So I'm going to try and talk in pictures and kind of explain that. But basically, that's why I put these in like highlights and italics. The relevant parts of the corpus callosum were smaller in cross-sectional area than the autistic participants. So that side view where we kind of looked at right there, it was like thinner or smaller. Okay? In Kim Peak, in Rain Man, in certain rare individuals, 1 in 10,000, 1 in 50,000, that they actually don't have that. It's just one large globe over top connected. Okay? But that's what they're saying. These findings suggest the neural basis of altered cognition in autism and entails a lower degree of integration of information. So if you don't have proper, like, if all the highways aren't going back and forth, you can't have proper communication in the lobes of the brain or wherever the nerves are going. So it's not just the corpus callosum, it's not just the bridge, but that's a big piece of what's going on, and we've known that. So that's 2007. So the last was 2009, and 2011, after the meta-analysis, what were they calling it? Preliminary? Kind of backwards. But I guess they'd already spent a few years doing that research, so they didn't want to go back and say, oh yeah, we'd already worked 3 years on that. So
my son had an MRI a couple of years ago.
Okay.
Does that mean I can get the data and like look at it?
I hope so. Now, there's an issue with doctors looking closely at x-rays and MRIs. Has anyone heard of like the ER or their doctor missing a stress fracture? Something really small that's on there? Like, we can't tell if the rib is broken or like they might have missed a cracked rib. Yes, that's what I would love to have, that, all that information gathered up and given to like researchers at the university. Because if it's 10% smaller, I mean, even with like a disc bulge, because in my office across the street where I work with like chronic pain and stuff, somebody might have a disc bulge, and it's like it's either bigger or smaller compared to the last one, and a lot of times the actual the report will say no change, and it's like 10, 20, 30% different, and they won't even notice or care because they're either not comparing close enough. But yeah, if you have somebody that's going to look at it that close, that they'll actually like see it if they compare it to other ones. That's why it costs a lot of money to do research. You know, the government is involved in a lot of that. They throw the money to universities, and not to throw a bias in the equation, but is medicine biased by what we call big pharma, by the pharmaceutical companies? Are there like, multi-billion-dollar companies that if they actually put everyone that they diagnosed with ADD or ADHD on the medication for the doses they wanted, would that be maybe double or triple what they're already getting billions of dollars wise for those kids? Of course. So when we talk about cofactors, yes, so there's like a 25 or 30 or so % chance of having like a temporal lobe epilepsy with autism. Does that really change the autism, so to speak? But does it give them a chance to maybe give you a medication for the epilepsy? So other side effects, the epilepsy medications? Are there, did Abbott blink hardly a bit when they got fined $3 billion? $3 billion when they were like prescribing Lyrica and several other medications for multiple different factors? I'm not anti-drug, Some of the patients I see with diabetes, and they're like, so now that I'm getting better, or like, when they first come in, they're skeptical, before we start treating them, before their blood sugar drops, 30 points, and before they're all the way better, so to speak. And they're asking, so can I come off the medication? I'm like, you realize that that's probably keeping you alive right now, okay? If your blood sugar went too high or too low, you can get severe kidney, eye, nerve damage. So it's designed to keep blood sugar from basically going too high. If it goes too low, that's a problem too. So if we're helping you bring it down naturally, and you start feeling better, but if it starts to go too low, when do you think the time is to maybe start either A, deciding to quit the natural therapies, or B, maybe start reducing medication? Okay, because if you're on the medication now, it starts going too low, it's like kind of an either or thing because you don't want to bottom out. So you need to be on the medication for the condition that supposedly it's treated for. But doctors do get kickbacks from pharmaceutical companies, we know this. The drug companies spend more on marketing than they actually do on research by far. But I'm not anti-pharmacy, I'm not anti-drug, I'm not anti-surgery. I'm just presenting the facts and the way that I see it. Okay, here's the cool thing. So Norman Deutsch, Michael Merznick, who I'll talk about later, Sandra Blakesley, V.S. Ramachandran, all these authors are the same doctors that you will see on PBS on a regular basis. So then they flip it on and see like Dr. Daniel Amen talking about improving your brain, losing weight, how being obese, having high blood sugar, having too much weight on can literally do physical damage based on the SPECT scanning. How different parts of the brain, like especially the right hemisphere up here towards the frontal lobes, doesn't light up as much, isn't as full with like ADHD. Daniel Amen, really cool. I mean, he's written like a dozen books, but he's on PBS. Well, so are these doctors. Norman Deutsch wrote The Brain That Changes Itself. And he put together a collection of a dozen or so different doctors who are known for their research in what is now called neuroplasticity. Has anyone hear about Lumosity? Anyone hear the commercial for that, where it's those little brain games that you play on the computer, and by doing these certain games, it helps to wire your brain up more effectively? That's neuroplasticity. Okay? So it's the fact that when one nerve and another nerve, these nerves start connecting better, more efficiently. That is just the ability of the brain to be able to wire and rewire is called neuroplasticity. It just means the plasticity of nerves. Okay? That unlike what they thought up until about the 80s or 90s, before they started doing SPECT scanning or functional MRI or diffusion tensor imaging like we saw, it's crazy, but they actually believe, like it's still the dogma from science, that they almost think the brain is hardwired, and then they were just trying to decide when it becomes hardwired at. Is it birth? Is it 5 years? 10 years? Age 18? Age 25? When does the brain become hardwired? Who wants to say 5 years? 10, 15, 25, over 50? It's never hardwired. It's always growing, it's always changing. Okay? It's like, when do the muscles become hardwired to a certain size? When do you want the muscle, when do the muscles become the exact size they're going to be throughout the rest of your adult life? Never, because you can go to the gym and work out and get them a little bigger, or you can quit working out, around the winter time, and Thanksgiving hits, and you get a little bored and start to shrink back down, and you complain to your fiance a lot, and the muscles can shrink. So it can get bigger, it can get smaller. The connections in the brain can wire up, and I'll show you a video of that later because it's really cool, and that's what neuroplasticity is. So we're working with the avenue of getting the brain to be able to wire in more effectively, because the whole use it or lose it process applies to muscles as well as the brain. So, I've got the page number on here later, I believe. Maybe not. But This book is available on Amazon.com. It's got all the best research, and it's 4 years old. I'm going to read this one just because. At 26 months, a child's plastic change is at its height. The right hemisphere, the one we've been talking about so far, the one that's been linked to autism, they've had a theory that it's strongly linked to autism. The right hemisphere has just completed a growth spurt, and the left hemisphere is beginning a spurt of its own. The right hemisphere generally processes nonverbal communication. It allows us to recognize faces and read facial expressions, and it connects us to other people. During the right hemisphere's growth spurt, from birth until the 2nd year, these functions undergo critical periods. So, it's weird, but it's true. All right? It'd be almost like saying the right side of the body starts getting stronger the first couple years, and the left side starts catching back up. But it's the brain. The left hemisphere generally processes the verbal linguistic elements of speech. Babies have a larger right hemisphere up to the end of the 2nd year, and because the left hemisphere is only beginning to its growth spurt, our right hemisphere dominates the brain for the first 3 years of life. So, the first couple years of life, they're both going through this growth spurt, but the right one more so. And at the end of the 2nd year, the left one's starting to catch up, so by the 3rd year, the left one starts to kick over, and every couple years it shifts until about we're a dozen or so years old. So it's right for a couple years, and then left, and then right, and then left. Very important when we talk about why the right hasn't caught up, because when is autism typically diagnosed? Is it after the age of 10? After the age of 5? Before the age of 4? Some say before 14 months. Some say about, you can see videos of babies' eye contact. I mean, they've done that. Teitelbaum did the research. And that, you can basically show people who have no experience with autism, just, the lay public, you guys are obviously much more educated because you're here and you've already had this exposure before, but just the general person off the street is like, what's autism? Right? And show them, okay, we're going to look for some of these kids and these kids, and you're going to divide them into category A or category B. We'll call these typical controls. The ones that seem to, you notice a difference between these, and just the lay public can look at that at 6 or 8 or 10 months easily and determine these kids don't quite have the same processing as these kids. It's different. So, if the right brain is supposed to be going through that growth spurt, and actually it's kind of a lie because it starts before birth. Okay? So the right brain is actually on its growth spurt when they look at preemies, okay? Or in dissection of corpses. So when they look at the right brain, they find immature networks on the right. So when they talk about immature networks, it's like if you look in a child's mouth before it's lost those teeth, what do we call those first teeth they have? Baby teeth. So you lose baby teeth. So after that, when they fall out and new ones grow in, you have what they call adult teeth. We're going to call the short-range networks. They're like little city streets. They're the small connections that can connect us to downtown, to Southtown, to Kokona's Furniture downtown. It's a very nice establishment. I bought much furniture there. Put a little plug in. But it's the short-range network, so it's like, okay, first it grows in towns. Kind of like we did before the Old West. I mean, when we were first settling America, it was like we first had colonies. Once we started getting established there, we grew out and we grew pathways. Then we started forming different colonies, different towns, different cities. So we have the short-range networks, which are considered the immature ones. They're supposed to be there. We're still supposed to have some. But if all the territory looks like that, if from all the way to one side of the Atlantic Ocean to the Pacific Ocean is all just those small streets, and we don't have that long communication, what would happen if you were to try to drive to California on a 25 or 35 mile per hour road like on Maple Avenue? It would take forever. And that's when they talk about the oscillation speed or temporal binding, or we'll talk about the Back to the Future problem, which is like if you have a signal that needs to go from one hemisphere to the other to communicate, or from the front to the back lobes to communicate, and it only has those short-range networks. It didn't take the time to start pruning, as they call it in neuroscience, where it starts only selecting the most important ones it needs for certain functions, which genetically, like the typical person, actually does have more short-range networks as we grow up on the left, but then longer communication on the right. So basically, we're finding baby teeth on the right side of the brain in autistics, to simplify it. Baby teeth of nerves. Okay? A lot of short intercross nerves, and not as many of the long-range nerves as we should see. So, Harvard psychiatry departments in the right, not the left, temporal lobe, we find increased omnidirectional, parallel, perpendicular diffusion. They find a lot of those neurons slapped together like downtown things are. Some streets going one way, aren't those a pain in the butt? You know, but not as bad as Newark. The downtown Newark, that whole loop around the courthouse, is a big mess. But these measurements possess very high ability to discriminate individuals with autism from those without, in the 90th percentile. So that's one of the big findings. Besides the corpus callosum, which is what? The Golden Gate Bridge. Besides that being decreased in connection, then also the right brain has immature networks. So here's the conundrum. Here is the problem. If when the right brain is supposed to be going through that growth spurt, if the communication, the bridge is smaller, especially in boys, but it's even smaller in autism spectrum, then how do you get that speed, the connection of the right and left to communicate? I'm going to jump to this because I want to see it real quick. So in pictures, in autism, the right brain is like processing on, let's say, Windows 95. Now we know from that, that's way before Windows 95. That's a pretty small screen. My first laptop screen was about that big, and it was Windows 95. Versus, you know, straight out of Minority Report with multiple screens, or when they're chasing down the bad guy in some futuristic show. Because in fact, if some of the symptoms that we see, can autism spectrum kids and adults have hyperlexia, have the ability to actually read and remember, like with Asperger's? And I'll refer to Big Bang Theory a little bit, because Sheldon, you know, isn't he just like super smart? He's like a PhD in 2 different things. So the left brain is involved with language and learning and fine details. And a lot of these kids and adults, I'll typically, you know, talk about the kids mostly, but they might be absolutely 10% are absolutely ridiculously good at processing information, just like Rain Man, okay? It's like hyper, like function, versus on the right side, it's hypo function. So that's the metaphor, because if the bridge between these two is already smaller, and they're supposed to be developing back and forth, and the right one never quite catches back up online, we're not saying that this is broken, are we? Did I ever say that? Okay. I said, not trauma, not stroke, not epilepsy, not tumor, nothing like that. But did it develop as effectively in the evolution of the computer, so to speak, or just the development of the brain, as that one did, just in a period of, you know, I mean, heck, in 10 years' time, that's almost what we went between. So the left brain is processing on Windows 2012, or maybe even 2020, if it's like hyperlexic, remembering everything. Versus the right brain is firing on at a lower speed. So the communication between the two, how hard is it to network a computer between Windows 2012 and Windows 95? Has anyone ever been able to do it? Has anyone tried? It's impossible. They're not running on the same processing speed. That's exactly what you're saying in the literature. So I've got to go back to it, because I've got to beat the dead horse, and then I'll get to some of the cool stuff here afterwards. Okay. Deutsch. By the way, it is my absolute favorite book on neuroplasticity. So if you want this PowerPoint, or write it down or get PowerPoint, because it is an amazing book, and it references all these researchers from phantoms in the brain that changes itself, Michael Mersnick's work. We'll see pictures of him later from PBS. I love having a camera on my phone now. I can get a picture like when something's on TV and email it to myself in no time. All right. So again, decreased right hemisphere traits. So we're looking at the person from behind, so we had the right and the left, that the right is hypofunction. Okay. Department of Pediatrics and Neuroscience, I like referencing because it's not me, it's not just me, it's not just Dr. Lowe, it's not just Dr. Carey. It's all this research put together to try and put it into a coherent whole to see that, all right, this is what the scientists basically at Autism speaks. The developer of research. This is what the National Institute of Mental Health, this is what they're all starting to say consistently, is that we recorded brain activity from high-functioning children with ASD as they complete a visual target detection test. The left hemisphere is specialized towards processing local features. So it's like, it's the details. The left is the details. It looks for like a little picture all the different processing, like what page something was referenced on, the ability to focus on the small part of the picture. The right hemisphere is involved with processing global stimulus. So that's why we talk about the left brain. It has more of the smaller, tighter wirings. It's downtown Zanesville. It's got all those streets it's supposed to. Okay? It still has some of the long range, but in many ways it's the baby teeth. But you're still supposed to have some. So the metaphor falls apart a little bit, but the right brain is supposed to have much more of those long-range bridges. So a lack of communication between the hemispheres and ASD, combined with typical hemispheric specialization, is a root cause for impaired categorization and the often observed bias to process locally, the small details. Because they really get into all those little details like that. They're ignoring the big picture, where everybody else is at, what everyone else is doing, and that's why they're focused on this one little topic. And that's why we'll get to some of the processing with the social aspects in a minute. They're not getting in there, like, you almost can't get them out of their own little world. And that's the goal, right?